spring of 2014, we are going to work on a small stellated dodecahedron that's 60 equilateral triangular faces. And we will make this out of glass with Hans Schepker in the spring geometry workshop. One of the products we'll make is this paper folding cube. You will see that there are 6 cube faces in this flexible image that you will make. The designer of this paper folding technique has created this image for you, and a couple of students have gotten together and managed to make one so far. So we're going to try to make a collection of these, and I'm going to try to break this task down so that we have some success in assembling it. And that's this item, the Snub cube. You will make 6 cubes from the 1x8 strips, 32 triangles from the 1x6 strips, and 60 fasteners for the 1x4 strips. So while every student can work on, folding these objects, it really is the resource managers who are going to keep these counted. It's really important that you have 6 cubes, 32 triangles, and 60 fasteners. It's really difficult to assemble this if you have extra pieces or if you're missing pieces. So let's take good care of that. Now, as you're putting these together and as you're analyzing the photograph of this picture and as you're analyzing the real one that we'll have in the classroom, or one of the real ones that we'll have in the classroom, you're going to see different parts. Just like the 12-pointed star we made on the first day of class, you will come to see parts of this figure. And I'll show you how I saw it as I was working with it. And that was as 1 cube with 1, 2, 3, 4 equilateral triangles and 1/5 triangle that was placed in the same position for each set. So I repeated this figure 4 times, and I used that for the 4 lateral faces of this square prism. And I'm going to try to translate this figure and show you what I mean. So when I started to assemble the figure, I saw it as a cube, or finally came to see it as a cube, with 2, well, let's call it a prism. Let's call it a square prism with 4 lateral faces, each with a square in the center, surrounded by equilateral triangles. I couldn't quite make sense of the extra pieces. We have 32 triangles. Well, it was clear that each edge of the square would have a triangle attached to it. And then it was clear that there would be at least 1 repeated triangular addition these faces, but then how the top was constructed and how the bottom was constructed, I couldn't really make sense of. So I started with the lateral faces, 1, 2, 3, 4, and then created 2 more. So I started with the 4 lateral faces plus a top here and a bottom. So top, bottom, 4 lateral faces. And I guess we should call that top base 1 or base 2, and that bottom base 1 or base 2, depending on what we call the top. And then we have 1, 2, 3, 4 lateral faces. Now let me stress, it's really important that you count before you start assembling. Okay, really important that you count before you start assembling. So, task managers, you've got to keep everybody together, and resource managers, it really is up to you to make sure that your pieces are counted before you assemble. You're also going to have 2 equilateral triangles left over as part of your assembly.
So I was watching Miss Rebel's video, and I was okay with the parts where she said that, you know, she had the 4 lateral faces, each with 5 triangles, and that she had 2 bases with 4 triangles. But 5 times 4 is 20, and 2 times 4 is 8. So 32 minus 28 is not 2. So she really has 4 triangles left over. So, yeah. So yeah, it's really 4 extra triangles because that would make 32. Total triangles, 32.
In last, and I want you to analyze this area around the vertex at every square. The vertex at every square is constructed, see this little 5-pointed star here? At the corner of every square you have 1, 2, 3, 4 triangles. And as long as you keep that consistent, your figure will come out symmetrical and spherical and can be contained inside a cube. So here's another example. At every square there are 1, 2, 3, 4 triangles, and as you rotate the figure, you'll see that that's true at the vertex, at each vertex of the squares. So once you have these parts assembled, you started with 6 cubes, 32 triangles, 60 fasteners. You created 4 lateral faces, 2 bases, and 2 extra fasteners. And it's time to assemble the lateral faces. So you bring 2 parts together and make 1 connection here, and bring another together and make 1 connection. Now I'm noticing something as I look at the way these went together. And I'm noticing that an even smarter way to put this together would be to reflect these images so that we have in every other tab. Let me see if I can show you that. So let's take a look. I'm gonna reflect every second image over a line of reflection and then turn off the original. line of reflection, and these extra points I got. And will this let me move this figure? Oh, that's interesting. One connector right here. Now this one's going to move kind of funky because of the, oh no, maybe not. Oh, these two are attached to each other. That's interesting. I'm going to try to copy this one so that I have a movable piece. Okay, so I can move this one over, but as soon as I start to raise it up to show you that it's going to go here, I kind of lose the other one. So you see what I'm saying, that we're just going to drag this one over, we're going to make its connection right here, and then you'll have a set of 4 lateral faces that you'll be able to wrap around and connect, and then play with the bases until they fit. But I'm going to suggest that you make your pieces as reflections of each other. Like so. Good luck.
And remember, it's 4 extra triangles, not 2 extra triangles. Total of 32. Count before you start. Good luck.